Welcome back to Kirsty's virtual classroom. Today in California Geology, we're talking about deserts. All right, so the three deserts we're going to focus on are the Great Basin Desert, the Mojave Desert, and the Colorado Desert, all of which are in southeastern California. Okay, so the Death Valley Desert is covered in the Basin and Range province. But the Mojave Desert and the Colorado Desert are their own provinces. Okay, so we've talked about the Mojave Desert and the Colorado Desert when we first introduced the provinces. Death Valley just happens to be in the Basin and Range province. Right, so let's take a look. Here's Death Valley in this northeastern portion. It's east of the Sierra Nevadas that run through right about here. And then down here we have the Colorado Desert, and then we have the Mojave Desert in here. Okay, so California deserts have the longest period without rain. So most of the vegetation that you see there is very minimal, and we see things like cacti and succulents, things like that. So the other areas that we might see prolonged periods without rain, and we also see that in Chile, in addition to the Mojave Desert. These are the longest time periods without a single rain event. So from 1571 to 1971, in Chile, their desert had a really long period, almost 400 years of no rain. And then from 1909 to 1912 is the longest we've seen in the Mojave Desert in Baghdad, California. They also experienced the highest temperatures ever recorded. In 1913, Furnace Creek in Death Valley had a temperature of 134 degrees. And then August 17th, 2020, Furnace Creek had the highest reliable temperature ever recorded, which was 130 degrees Fahrenheit. So this last summer was really, really hot. What's really interesting is sometimes you can take a look at the temperature in Death Valley, and sometimes Fresno is hotter than Death Valley at times, and that's when you know something's really wrong. But Death Valley gets very, very hot. Right, so here's Death Valley in relation to most of the other areas. Remember, this is San Francisco Bay Area. Down here is LA, and then Fresno's right about there. So Death Valley borders up against the California-Nevada border. There are lots of alluvial fans in the area, and alluvial fans are basically outlets of material. So this is an accumulation of soft sediment. So this could be sand, silt, clay, that eroded from these mountain ranges and then followed this drainage and then fanned out into the valley. So they look like big fans, and alluvial is the combination of sand, silt, clay, kind of a mixture of things. So we call them alluvial fans, and they are primarily driven by flash flooding. So when we have very quick, rapid rain in the area, it'll fluff a lot of the material that's been sitting there for a long time without rain into these drainages and then push them out into the valley. We also see fault scarps because there is a very large fault running through Death Valley called the Death Valley Fault Zone. So on these alluvial fans, sometimes we see fault scarps, and these are from dip-slip faults rupturing along these areas. So this portion of the block dropped down and this portion went up, and so we see this scarp that's illustrated and shows the fault that continues through this area. Here's another look at the alluvial fans. So this image I've already shown you. Here's another look at the kind of mixture of material you might see in an alluvial fan. And sometimes if it continues, the channels can continue and create more channels into the existing alluvial fan. All right, looking at the Mojave Desert, this is in southeastern California, so we're down here. It's its own province, remember. Okay, so this hosts the Joshua Tree National Park, the desert tortoise. We see sidewinders and very old rocks. Some of the oldest rocks in California are actually in the Mojave Desert province. They are up to 2.5 billion years old. So remember, the age of the Earth is 4.6 billion years old. So 2.5 billion years old is pretty old. So the oldest rocks reveal this paleo environment that's similar to the Gulf of Mexico. So if we look at this, this is the Great Valley Unconformity, or sorry, the Great Unconformity. Here we have the Pacific Ocean, shallow shelf where we see sedimentary deposits, and then a lot of this stuff down here is going to be the basement igneous, metamorphic, some sedimentary. And then we see the subduction of the Farallon plate here. So we have subduction zone that forms along this western margin. We see regional uplift, erosion, and volcanic arcs. Lots of volcanic intrusion. And then from then we see extensional spreading of the Great Basin region, which began about 30 million years ago. There's a younger strike-slip fault that creates, which is the San Andreas fault system. We also have the Garlock fault system, which is a left lateral strike-slip fault. And then we do see a lot of alluvium start to fill in these basins, and very little volcanism to the east. So we also see this guy, the desert tortoise. He lives in the Mojave Desert. Looking at the Colorado Desert, which is to the very southern portion, just east of LA. Here is a better look at it. So we talked about the peninsular ranges. Now we're looking in this Colorado Desert area, which does extend further than California, just like the basin and range extends further than California. So it includes the Salton Sea, Imperial Valley, Coachella Valley, and then the Anza-Borrego Desert. So the Salton Sea is known as death in the desert. It has been basically abandoned. It's got a very high salinity content. So swimming in there can be kind of fun because you'll float very well. But it's kind of yucky to be in. Not a lot of people like to hang out around there. So here's an image of what the Salton Sea desert area kind of looks like. So the Colorado Desert is bound by faults from the San Andreas Fault and the San Jacinto Fault along the southwest boundary. So northeast is the San Andreas. This is a pull-apart basin that extends from the East Pacific Rise in the Gulf of California. So the pull-apart basin is being created by the interaction of these two faults. We have a lot of desert erosion, mostly driven by wind and water. Like I said, the water is going to be mostly flash flooding. So here's kind of a picture of what flash flooding might look like. There's a lot of rain that comes down really quickly. Not a lot of material has been eroded very rapidly, very recently, and so it drags a lot of loose sediment with it. There is something called mushroom rock in Death Valley, which was actually formed by wind erosion. Sand cannot become airborne over a few feet, so the rock is heavily weathered in its center, and then towards the top, because the sand particles haven't been picked up this high, it hasn't been eroded as rapidly. So we get this kind of differential weathering. We also see something called desert pavement, which forms as wind erodes finer grained material and the coarser grain settles in an interlocking manner, which kind of resembles pavement. So this is actual pavement here. This is desert pavement. So because there's so much wind erosion and it can't pick up these bigger particles, it picks all the smaller particles up that are in between these bigger particles, and then eventually all of this kind of compacts together and forms something that's similar to actual pavement. Here's some images of the flash flooding that I was talking about, so you can kind of see it's actively raining here, and a lot of this material is coming down quickly because this is it's not usually occupied with water, and rain does not occur very frequently. So because of that, all of the material is mostly loose. And so it flows really quickly and takes all of the material with it. Well, not all of it, but a lot of the finer particles with it. And that's why it kind of looks very murky in this water. Here's another example of what flash flooding might do. So this was in 2015. It completely took out a road in Death Valley because this material does not experience quite a bit of rain or erosion regularly. But when we get a massive flash flood, it can remove a lot of the material. Here's another image of flash flooding in 2004 in Death Valley. These bathrooms basically sunk from the erosion and the water that came through here. Here's another image of what flash flooding might look like in Death Valley. This was in 2010. So one of the issues with some of the sites that you can visit in Death Valley is that a lot of them are dirt roads. And there are fairly decent dirt roads where these, regular cars can drive down them. You don't need a four-wheel drive or necessarily very high clearance because there's not a lot out there. It's usually just compacted alluvium, basically. But if a flash flood occurs when your car is parked on the side, you might have some trouble getting out. Here's a really bad one in the Mojave Desert in 2015. This entire truck got engulfed, and so this is actually a highway that they are now having to excavate. They've got a big excavator out here trying to pull the material out so that they can get everything cleared. Let's talk a little bit about desert dunes. So you've probably seen sand dunes on the beach, but they also exist in the desert, especially because we have a lot of wind erosion that occurs. It picks up fine particles and deposits them in an area. Here's an example of the Death Valley dunes. This is Mesquite Flat Dunes in Death Valley. You can walk up and down these. The cool things that you can see in here are all those ripple marks. So these ripple marks are formed from wind erosion and kind of show you the direction the wind was blowing. But in Death Valley, what's really cool is the wind blows back and forth. So it changes direction pretty frequently. So these dunes change frequently. The dunes don't always look exactly the same every time you go. It's like when you go to Half Dome or you go to Yosemite Valley, it always, for the most part, looks the same, right? But when you visit sand dunes, the cool thing about them is that they're dynamic. They move, they change depending on wind direction. So these dunes, even though they're massive amounts of sand, will change much more frequently. Here's another example of Mojave Desert dunes. These are the Kelso dunes. These are also very cool. They look a little bit different. They look like they have a little bit coarser material in some areas in comparison to the Death Valley dunes. There's some dunes in the Colorado Desert. So every desert has dunes because of the amount of wind erosion that we see. So any desert that you visit, so it's very iconic. The Sahara has dunes, like the Colorado, the Mojave, all of our deserts have dunes. All right, let's talk about ancient lakes. Lakes are huge in the desert, even though they're not really there anymore. So the paleoclimate, which would be paleo meaning ancient, and climate, obviously we're talking about long-term weather patterns, right? So in this instance, we're talking about lakes and rain patterns in these desert regions. From 2.5 million to about 12,000 years ago, huge lakes dominated these areas. So we have Cyril's Lake, Prominent Lake, Owens Lake. We had very vast lakes in the southeastern portion of California. So we see a lot of evidence of these lakes as well. So here, what's really cool is we see these etched lines in the side of the mountain, which you can probably see in a lot of reservoirs that are losing water. So like the St. Louis Reservoir, just west of Los Banos, when you're driving down 152, that reservoir has actually lost quite a bit of water recently, and you can see kind of the delineation lines of where the water levels used to be. I mean, we can see that in these mountain ranges as well. So these are ancient shorelines of Lake Manly in Death Valley. And so as these lakes have dried up, we oftentimes see mud cracks. So we briefly talked about these, but the quick evaporation of water from the surface creates these mud cracks here that you can see, and these can be preserved in rock as well. Other areas like Owens Lake have been completely drained. This used to be a massive lake, and this lake disappeared not from climate, but rather from very greedy people in Los Angeles that needed water. And so the California aqueduct is hooked up to this lake. So any snowmelt that comes down the eastern side of the Sierra Nevada is then basically shipped via pipeline to the Los Angeles basin to supplement their water usage. So here's a look at Owens Lake as it used to be. So this is in Owens Valley on the eastern side of the Sierra Nevada. So remember, this was the beginnings, so to speak, of the Basin and Range province here. So near the 19th century, Owens Lake was around 110 square miles in size, which is a very big lake. And it was one of the largest natural lakes in California. So this lake was not dammed. This was a natural lake that was being fed from the snowmelt off the Sierra Nevada. And after it was diverted in the early 1900s to Los Angeles, this is what it started to look like. So we see a lot of the salt deposits being left behind as it's pulled and basically pumped into LA. So now we see things called dust storms over Owens Lake because there's so much salt and fine debris left over. There's a lot of wind that rolls through Owens Valley. And so instead of it just rolling over the lake, it now rolls over all of this fine sediment and salt deposits that have been left behind, and kind of creates this really unhealthy and difficult to maneuver through dust storm. The Trona Pinnacles are also in this area. So the Trona Pinnacles formed at the bottom of a 640-foot deep lake during the Pleistocene. So all of these are part of the Trona Pinnacles. These are tufa towers that are formed from calcium-rich springs that bring water up, and it bounds with carbonate lake water. And they form limestone. So all of these are made of limestone. And the only way that these form is if they are underwater. So that's how we basically have determined that there used to be a lake in this area, is because all of the material that is deposited here and the formation of these tufa towers can only occur if they are underwater. Here's another look at the Trona Pinnacles. They're pretty spectacular to look at, actually. So we also see tufa towers in Mono Lake. If you've ever been to Mono Lake, it's a fairly small lake nowadays, but it does have some of the tufa towers. And here you can also see some of those ancient lake shorelines. So this lake used to be larger as well. And you can see all of those old shorelines where the levels used to be. And for reference, this is the Sierra Nevada mountain range right here. Here are the tufa towers in Mono Lake. There's lots of imagery of Mono Lake and how spectacularly beautiful it looks, especially when you can see the reflection of the tufa towers on the lake water, the lake surface, excuse me. Here's some more look at those tufa towers. Remember, these are made up of limestone, so they easily erode as well. So we've seen the loss of some of the tufa towers in recent years, but hopefully they last a little bit longer so that we can show future generations things like this. All right, let's look at mineral resources. So ulixite and colemanite are found mostly in the Mojave Desert. So both ulixite and colemanite have very high concentrations of boron, and boron is very, very important economically because we can use it in fire retardants. And a lot of it is actually mined out of Boron, California. So this is actually in Mojave. This is a look at some of those crystals that you might see in this mine. Here are some of the borax crystals from the Mojave Desert and the Death Valley area. So the discovery of borax in Death Valley actually happened in 1881 by Aaron and Rosie Winters. This is an image of them. If you click on this link in the PowerPoint, you can learn more about it, but I'll tell you just a little bit. So they started with this borax to help with cleaning products. So they were trying to sell it to women in the 1800s to try to get it, economically significant, if you will. So there's a lot of these old kind of posters that they would create. It's for sale everywhere. It's pure borax, and they try to make it look sort of heavenly, if you will. And then they kind of show you all the uses for it in your house. So there was a 20 mule team story that came out of Death Valley. So mules were used to haul this borax from Death Valley to Mojave, where there was a railway. So there wasn't a railway or a railroad in Death Valley. So these mules had to move it from Death Valley to Mojave. They usually used teams of 8 to 10, but they could not complete the journey. So they used this idea of 2 10-mule teams side by side, making a 100-foot long team that took 10 days to carry 10 tons of borax from Death Valley to Mojave. It's pretty incredible, the things that we did in the 1800s. So if you've ever bought borax for your laundry, you've probably seen the 20 mule team. On here, the 20 mule team was from 1891. And this is Francis Marion Borax Smith. So he was the founder and owner of this 20 mule borax team. Here's a photo of the team. So you can see this is a very long train, and they have all of this borax that they're hauling from Death Valley. This one actually has 800 pounds equipped. So you can see some of these wagons in Furnace Creek in Death Valley. So they have some of the old historic wagons that they used to ship the borax in. And here's a look at the mine in Boron, California. It's an open pit mine, so they do have these steps. That's to help with the integrity of the slope, essentially. And it also helps drive in and out of the mine. So this is active today, and you can go visit it if you're ever in the area. So that's it for deserts. I will see you guys in the next video. Bye!